Hey guys, Mr. Lauer here. I wanted to just take a look at a few problems here on this quadratic forms worksheet that I assigned. This is the assignment for Wednesday, April 1st. Before you jump into this assignment, what you're going to need to know is the different quadratic forms that we have, or the different forms of equations for parabolas. So this is a document that I've shared with you and asked you to review this for one of your attendance quizzes. You're going to want to have this handy probably, or at least, if you don't have it handy, you're going to have to know these things. Now you are going to have to know these forms for the test that we're going to take in the next little bit here. So you're going to have to memorize this, but this is a nice cheat sheet for you that you can look off of. If you need a little bit more detail on each one of these forms and how these different pieces affect the graph of the parabola, I made several videos where I graphed each of these forms and in Desmos, and I made little sliders for them, and I kind of played around, did some experiments in there. So if you need some more background on these forms, I would go back and watch those videos. I believe that was from Monday. So let's jump in here and look at some of these problems here in this assignment. And these are going to require us to know these forms, but they're also going to require us to do some algebra here. So it's not just a matter of knowing the forms, it's also a matter of kind of converting between them. So this first problem set here, it says convert each equation from quadratic form to intercept or factored form, then find the x-intercepts. So what we're looking for is we want it to look like this. And we're starting with something that looks like this. Right? And we know that intercept form can be found by factoring a quadratic that's in quadratic form. So all we're really going to do is we're going to factor this guy, and then we're going to find the x-intercepts. Okay? We're pretty good with factoring by now. We've practiced a bunch, and we practiced last week, so hopefully this is kind of familiar. If we're factoring this trinomial, right, the first thing we need to do is look for a common factor. So if we look at all these, and we're like, okay, 3, 24, 27, well, 3 goes into all of those. Also, since we have a leading negative here, that the leading coefficient is -3, we're going to factor out that negative as well. So what we want to do is we want to factor out a -3. Or in other words, the greatest common factor of all these terms is -3. So we're going to undistribute basically a -3 from each of these terms, which is going to give us 3 terms. Okay? So if we undistribute a -3, we've got to think -3 times what gives me -3x squared. So this has got to be an x squared. -3 times what would give me -24x. Well, 3 times 8 is 24, so this would have to be a plus 8x right here. Okay, -3 times 8x is -24x. And then back at the end we want a positive 27. So 3 times 9 is 27. That means we need a -9 right here. Okay, so that's the first step, factor out the greatest common factor. The next step here would be to factor this trinomial. So this -3 is going to come along for the ride. But this is the trinomial we have to factor now. So kind of like we did last week, we can make our little x here. And we're looking for two numbers that multiply to -9, but that combine to give us a positive 8. Okay, we know that we're going to have something that looks like this. Right? We're going to have an x and an x up here because we need to multiply to get x squared. That's the only way we can really get there. And so the two numbers that go back here, they have to multiply to -9, because when we FOIL this times this will give me -9, and then we have to add to positive 8. So it looks like those two numbers are going to be 9 and 1. And we're going to have a positive 9 and a -1. So if I combine these, I get 8. If I multiply them, I get that guy. So the two numbers we're looking for then is a +9 and a -1. Okay, so there is my factored form. We'll just add the f of x back in. Okay, and in my factored form, remember that these guys right here, the p and the q, those are my x-intercepts. Okay, so I got my stretch factor up front, I got my x-intercepts. Now we want p and q, not minus p minus q. So whatever is in the parentheses here, we're going to take the opposite of that, and that's going to be our x-intercept. So here I want not a +9, I want a -9. Okay, so our x-intercept, one of them is going to be -9, 0. The other x-intercept is going to be positive 1, and since, again, these are coordinates, we're going to do something like this. So the x-intercepts are coordinates. You can kind of say, like, well, like negative 9 and 1 are going to be like where their intercept. So if you put negative 9 and 1, that, you know, that's pretty much there. I'm just going to write them as coordinates because x-intercepts are points. So we wanted to convert the quadratic form to intercept form or factored form, which we did, and then find the x-intercepts, which we did. Okay, so that's number 2. I'm going to leave these 3 for you guys to do. Odds answers are included in this assignment. Okay, let's jump to the next problem set, and I'll do one of those with you. Okay, so we'll do number 6. Okay, convert each equation to quadratic form, from quadratic form to vertex form, then find the vertex. Okay, so if we need to know what vertex form is, right, vertex form looks like this. And then the vertex is going to be h and k. Right, so we want it to look like this. We've actually done problems like this before. It's been a while, so I wanted to kind of review that with you. Okay, so putting this in quadratic form. What we're going to do here is we're going to use a complete the square strategy, because when we want something that looks like this, right, we want like this binomial squared kind of thing. And if we're going to have something that looks like that, we're going to have to complete the square. So let's do that. First thing we're going to do is we have to get some stuff in a place and in a form where we can actually complete the square. So the first thing we're going to do here is we're going to get rid of this number. Whatever number is floating around, we want to get it to the other side. So I'm going to do plus 197 here. Okay, so I have y plus 197 equals negative 2x squared minus 40x. Okay, the next thing I got to do is I got to get this guy, the x squared, up by itself. When we use our complete the square strategy, we don't have a number sitting in front of x squared. We don't want that there. So in order to get this into a form where we can actually complete the square, we have to divide every term or every part of this equation by this guy. Okay, so we're going to do that on the right hand side a little bit differently than we do it on the left. Let me show you what I mean by that. So what we're going to do is we're going to divide everything over here by negative 2 and divide over everything here by negative 2. Okay, now this here we're not going to change because we're actually going to go back and undo all these things in a minute because we want to get y by itself. So we're not going to bother like simplifying this. We're just going to simplify this right hand side. So let me get over here on the side a little bit so we have some more space. This is basically going to turn into this part right here is going to turn into x squared because we have this. Well, let me go one more step. Just to make this will make more sense. So both things on the right hand side, both these terms need to get divided by negative 2. Okay, so our next line will be y plus 197 over negative 2. That's not going to change. And on the right hand side, these will cancel, and then we're going to get the negative 40 divided by 2, which will be positive 20. So we have x squared, okay, and then we have plus 20x. Okay. Now we're ready to complete the square, so we're just going to figure out what number has to go here to make this a perfect squares trinomial. Okay. So remember, to do that, we got to figure out what half of this is and then square that number. So half of 20 would be 10, and then we're going to square that to get 100. So I'm going to go plus 100 right here. Okay, now I also have to do plus 100 on this side. See if we can squeeze that in over here. Okay, and again, I don't care about simplifying the left-hand side. That's not part of our strategy here because we're going to try to get y by itself in just a second. So our next step then is to just kind of factor this. Now remember, now that this is a perfect squares trinomial, I can rewrite it as x plus 10 squared. Right? That's the whole point. The whole right-hand side can be written as a binomial squared. And how did I get this number? Again, it's half of this middle term, right? So 20 divided by 2 gives you 10, and 10 squared gives you 100. That's kind of the relationship here. Okay, back over here on the left-hand side, I have y plus 197 over negative 2 plus 100. Okay, so now we're going to start moving stuff back over to the right-hand side. We got to get rid of all the stuff away from y because in our vertex form we want y equals. Okay, we want it to look something like this: y or f of x equals a times x minus h squared plus k. That's what we're going for. Okay. So we got to subtract 100 back over. Okay, so minus 100 minus 100. Okay. This is kind of the tricky step. We got to multiply everything by negative 2 to get rid of that negative 2. Okay. So if I multiply this by negative 2 and I multiply everything over here by negative 2, make sure you can see that okay. What we're going to get is the negative 2's cancel here, and then I get y plus 197 equals, now I'm going to distribute this negative 2 here because there's this guy and this guy. So negative 2 x plus 10 squared, and then negative 2 times negative 100 is plus 200. Okay. And the last thing I got to do is I got to get y by itself. So minus 197 minus 197. Okay. So y equals negative 2 x plus 10 squared plus 3. So we move everything that doesn't have an x over to the left-hand side. We complete the square on the right and factor, and then move everything else back over to the right-hand side. Okay, that's our strategy here. So this is the vertex form. This is what we wanted. Here's our vertical stretch factor A, and then our vertex is going to come from, like, it's the h and the k, right? So I want the opposite of what's in here, which would be, so this is a plus 10. Make sure you guys can see that okay. I want the opposite of what's in here, which will be a negative 10, and then I want to take this guy, and that is my vertex. Okay, so that is how you do these problems here. Okay, you move everything that it doesn't have an x over to the left, divide if we need to, like this. In this case I would divide by 6 on both sides, complete the square, and then move everything back over to the right hand side. Let's do one more of those just because those are a little bit tricky and it's been a while. So I'm actually going to, let's do 5, and I'll kind of help you get started with this one as well, and then you guys can try these ones. Okay. So on this guy here, we are going to start by subtracting 97 from both sides. Just getting everything that doesn't have an x away so we can complete the square on the right hand side. So we get y minus 97 equals 6x squared minus 48x. Okay, if we're going to complete the square, we need to divide both sides by 6 everywhere. So we're going to divide by 6 here. On this side, we're going to divide by 6 here. Now, this side we don't care about simplifying because we're going to move everything back over to the right anyway. On this side, we have to divide both of these pieces by 6. So this right-hand side equation ends up being 6x squared over 6 minus 48x over 6. So the 6's are going to cancel here, and then I have 48 over 6, which gives me negative 8, because 6 times 8 is 48. So what I end up with, my next line here, is y minus 97 over 6 equals x squared, right, because the 6 is canceled, minus 8x, because the 48 divided by 6 is going to give me 8, so negative 8x. Okay, so the left-hand side is getting a little more complicated. The right-hand side is now in a form where we can actually complete the square. So we got to figure out what's that magic number. What's that magic number that makes this a perfect squares trinomial that we can then factor? So we want half of this guy, right? Negative 8 divided by 2, that's negative 4. And then we square it. So that's going to give me a 16. So I want plus 16 here, but I also need a plus 16 on the left. And we're not going to worry about trying to combine like terms or simplify on the left or get common denominators or anything like that. We don't care about that. We are just trying to complete the square on the right hand side. Alright, so now this guy is a perfect squares trinomial, which means we can write it as a binomial squared. right? And how do we get that number? It's half of the middle term. So it's negative 8 divided by 2, which is negative 4. So that's how this trinomial factors. It factors to this guy, okay? X minus 4 squared. Okay, so we're making some progress here. On the left-hand side, we have this kind of ugly stuff over here. All right, so now we just got to get everything over back to the right-hand side. So the first thing I'm going to do is subtract 16. Okay. Next, I need to multiply both sides by 6 to get rid of that 6. So multiply this by 6. Multiply everything over here by 6. Okay, so 6's cancel. Now here, this is the tricky part. We got to distribute. So 6 times this chunk, and then 6 times negative 16. So let's rewrite this. On the left-hand side, I have y minus 97, because the 16 canceled, the 6 canceled. Like I'm already done with those pieces. On the right-hand side, I have 6 times x minus 4 squared. And then I also have 6 times negative 16, which is going to give us a negative 96. Okay? We're almost there. All we got to do is get y by itself, and the last step we got to do is just add 97 and add 97. Okay, so we get y equals 6 times x minus 4 squared plus 1. Negative 96 plus 97 will be 1. So that is our vertex form. And for our vertex, I want the opposite of what's in here, so 4, and then I'm just going to take this guy without changing it at all. That's my vertex. Okay. All right, so there's 2 examples for you. Hopefully that helps. Now, just to kind of give you a heads up, in this one right here, there's not like a number in front of x squared. So this one's actually kind of easier. You don't have to end up dividing. Like in this step right here, I had to divide everything by 6 to get rid of that 6. Here you don't have that. So this one's actually not too bad. In this one, this is going to be more like the other two, where you're going to have to move the 8 over, subtract 8 from both sides, then divide both sides by 3, and then you'll complete the square from there. So hopefully that helps. There is going to be one of these on the test we're going to take, the next test that we take, so I want to make sure you guys know how to do this. It is something that we did before, so I don't know if you guys remember that, but this is kind of a review of something that we already did, so hopefully it's kind of familiar. I'm going to stop the video here, and we'll come back in the next one with a few more problems from the next problem sets.